By now, we've realized that everything is energy, the power to move something or make something happen. Because everything either does something actively, kinetic energy, or has the power to make something happen, potential energy. We've also observed the tiniest particles of energy and have pieced together that they're actually teeny little systems of energy with negatively charged electrical energy on the outside, electrons, which when channeled make electricity, orbiting around nuclear energy on the inside, protons and neutrons, which collectively is some very powerful stuff.
Each atom in this wood has a nucleus made of protons and neutrons, and the energy that binds them together is one of the most powerful sources of energy in the universe. If you could split one of the atoms of carbon or hydrogen in this log and rip those protons and neutrons apart, it would release some of that energy. There's so much nuclear energy in each atom that if I could unleash all of it that's in this log, there would be a giant smoldering crater where I'm standing, and everyone in the town of Missoula, Montana would be dead.
So now we know just how powerful each subatomic energy particle truly is and can be. Nuclear energy can blow things up, and electrical energy can shock. And we know what happens when those energies escape. Lightning happens when the negative charges, electrons, in the bottom of a cloud are attracted to the positive charges, protons, in the ground. But fear not. Generally speaking, our atmosphere is a very good insulator that stops or inhibits electric flow. So a tremendous amount of charge has to build up before lightning can occur. Thunder is when that electrical energy flows from the cloud to the ground. It's like a very big waterfall of electrons or electricity. When do you know lightning is about to strike? Well, electrical charges in the atmosphere just before a strike can lift hair into the air, providing nature's last warning of a bolt from the blue. Luckily, these guys made it out okay. We also know that nuclear energy, or the protons and neutrons, is what we extract to power up so much of this country through nuclear power plants. We do this by shooting unstable atoms with neutron guns to mess up the balance of the nucleus, thus releasing that nuclear energy, which is essentially sucked up to power our electricity. Now, is nuclear energy truly good for us? Well, obviously extracting the power to power us up is awesome. It's what happens after those atoms are all rearranged to extract the nuclear power. See, that messes up the order of things. And when that happens, nature can get really upset. It confuses the mathematics. Nuclear energy doesn't necessarily pollute the air, but exposed nuclear waste can both kill and mutate cells, leading to cancer.
Which is why people working in those factories have to be very careful.
And it must never leak out into nature, lest we destroy nature herself. So while the comics say it can give us powers, it would actually kill us or make our cells very sick, like cancer. Which is why we have to speed through radiation at insane speeds to not be impacted. Check out how we figured out how to solve that problem to get to the moon.
There's an invisible magnetic force field surrounding our planet, protecting us from harmful solar winds that could annihilate Earth. But this protective blanket is also a swirling ring full of deadly radiation. First, there's the inner belt, which is comprised of protons. And then the outer belt, which has mostly high-energy electrons. High-speed subatomic particles can tear through DNA, increasing the risks of cancer and other diseases. It was up to NASA. Scientists determined that if the speed of the Apollo spacecraft was about 25,000 kilometers per hour, it would take about 52.8 minutes to pass through the belt. The radiation dose received during that amount of time would be, at most, 11.4 rads, and that's without the protection of a spacecraft. Since a lethal radiation dose for a human is 300 rads in 1 hour, NASA deemed the missions a go.
But remember, that means you need to fund and power energy that will launch a rocket 25,000 kilometers per hour into space, while risking falling into orbit around the Earth, any other planet, and our star, the sun itself. Gives a whole new reverence for astronauts, doesn't it? And a whole new understanding for the energy contained inside of atoms.